All right, let me give you some hints for problem 8 because it's some of the things you need to do are things you wouldn't necessarily think of immediately. Um, they don't have anything really to do with center of mass directly, but they need to be used with center of mass in order to solve the problem. So the first hint that you'll want is that density is mass divided by volume. Let me draw the soda can real quick here. So we got soda can top, and then the cans down like that, and then we have soda inside at various levels. And the soda leaks out the bottom. There's a hole in the bottom. So what you'll need to do, here's the bottom here. What you'll need to do is, of course, in the x-com equation, right? You got mass. Mass is in there. So here's where density and mass are going to play a role. But the thing is, you need to find the center of mass, the lowest position of the center of mass. And so what's the mass of the soda here? I don't know. But what you do know is that the density of the soda doesn't change. Just because the soda is leaking out doesn't mean the density changes. And so you know that the density of the soda when it's full is the same as the density of the soda when it's down at the lowest center of mass. And so you got a little tiny system of equations there. So density, by the way, this equation becomes rho as density is m over v. So density of a full can equals density anywhere else. We'll just call it x. So you need that. Then you also, the last hint I'll give you is that where is the x center of mass the lowest? Well, if you think of, so the center, I'm not going to answer questions A and B for you, so I'm not going to talk too much about this, but the center of mass as the soda empties is obviously moving, right? Center of mass, I'll just give you a slightly hint. The center of mass, you should be able to easily think of this. The center of mass of both the soda and the can together is dropping. It's going to reach a lowest point because the problem asks where's it lowest. So you could think that there's a speed to the center of mass. The center of mass is dropping down, reaching its lowest point. So the lowest point, the speed of the center of mass must stop there, and maybe even turn around, possibly. So what's the relationship between position and speed? You got it, derivative. So it turns around when the speed of the center of mass is 0. I'm not going to put a unit, just speed of 0. So what's the calculus relationship? Use that, set the speed equal to 0, and that should give you the lowest point somewhere down here-ish for the center of mass. And those are my hints. Hopefully those help you along the way. Other than that, it's just a center of mass problem using good old this equation here. You're not going to need this, even though I talked about velocity. You're not going to need this equation. Just center of mass. And the individual masses here, you're going to relate with density. Alright, bye-bye.